For our next example, when we see negative cubed root of negative 64, we want to say, oh, two negatives cancel out. But that's not the case. We have to go through our order of operations. That negative in front means negative 1 times, right? It gives the coefficient. That cubed root, that's an exponent. As we said, the cube root mirrors that cube, right? The index mirrors the exponent. I got to figure out that power first. In this case, I know some of us are thinking because that's a negative, it wouldn't be possible, it wouldn't be real. But remember, because that's an odd index, not only is it possible, but it is negative. In this case, again, it's negative 4 because negative 4 times negative 4 is my positive 16 times negative 4 is my negative 64. Now, times that negative 1 gives me a positive 4. Don't think those negatives canceled out just to get a positive. It was because of those order of operations made it positive. And here's why we can't just cancel them. Think if I had negative square root of negative 64. Impulsively, again, we see the two negatives and we want them to cancel. Not the case. Remember, order of operations, negative 1 times. But now, when we have that square root of negative 64, no negatives under the even index. It was no negatives underneath the square root. No negative radicands. What we called it was not real. Well, negative 1 times not real is still not real. Multiplying it times a negative 1 isn't going to make it real. We still can't graph it on a number line in the coordinate plane. If it's not real, multiplying it by a negative isn't going to make it real. And you'll see for all of our answers, almost all of them are going to have an option for not real. Now again, we'll define this later. We'll talk about a way that we can address that, but it's just going to be a whole set of numbers, not real numbers.